Hey, so today we're going to be solving some optimization problems. If you saw the previous video of Introduction to Optimization, that's where all of these little guidelines in the corner are. So those are just like general steps to solve for a problem or solve an optimization problem. I'm not going to be solving the problems while labeling each step. I don't think that that's helpful, and I don't think that would be fair to people who don't want to use those steps, myself included. I don't usually go through each step, but I do know that they help people, so I'll keep them in the corner, and you can probably see where I use each step. The only one that I'll skip is number 4, most likely, of like actually labeling the domain. That's usually just logical in my head. So let's do a practice problem to get into it. I'll probably just do 2 problems and you can follow along since this is mainly to solve. Okay, a manufacturer wants to design an open box with a square face and a surface area of 108 square inches. So we can go ahead and draw a little box. This is going to be the worst box you've ever seen. It's open, so you can see inside there. I'm going to get rid of the title there just so it's a little easier. Square base, so that means these 2 sides are equal, so we'll label them X, but it doesn't say anything about the height, so we'll label that H. Surface area is 108 square inches, so surface area is going to be that little square at the bottom plus the 4 sides. So 108 is equal to X squared, that's the bottom square, plus 4, since it's 4 sides, XH, because it's X on one side and H on the other side that we're multiplying by. And then, okay, surface area of 108 square inches. What dimensions will produce a box with maximum volume? So we can say V is equal to X squared times H. So if we solve for H with the surface area equation, let's do 108 minus X squared over 4X is equal to H. Let's solve it a little more actually. 108 divided by 4 is 27, X to the power of negative 1 minus 1/4 X. So that's H. And if we take that V, let's bring that E down here, and this is the maximum volume, then maximum volume is equal to X squared. Let's plug in for H. We get 27x minus 1 minus, to the power of negative 1, 1/4 x. And we can multiply that in. V is equal to 27x minus 1/4 x cubed. And then we go into our proper optimization using calculus techniques, where we take the derivative of volume to make this an easier thing to solve for. 27x, that will be 3/4 x squared. We can break that out, so negative 3/4, let's take that out. I think I included an x, okay. Get rid of this x there. 27 minus 3/4 x squared. And if we take out that negative 3/4, x squared minus 36. 36 times 3/4 is 27. So then x has to equal plus or minus 6. Well, if we think about this logically, this is where the number 4 feasible domain comes in. You can't have a negative number for a distance. So it can't be negative. So x is equal to 6. Then if x equals 6, then we have to solve for h. So in order to solve for h, we can plug that back in to 108 is equal to, because we don't know the actual maximum value, you don't want to plug into the volume equation. We want to, I think I said value, maximum volume. We want to plug in, we don't want to plug into the volume equation, we want to plug into the surface area equation. So 108 x squared plus 4xh, that is 108 is equal to 6 squared is 36, plus 4 times 6 is 24h, and if you solve for h, you get 3. So the dimensions of this box are 6 by 6 by 3 inches. And that's your answer. If I went too fast, feel free to go back and look at it, but generally you want to be able to solve these problems pretty fast. So, trying to erase all of this. This is not going well. Okay, I'm going to do it like that first. I can't see where the thing is, so I'll shrink it down. Okay, there it is. There we go. So let's do one more practice problem. I'll try to slow down a little bit more for this one because the one that we just did was fairly easy. You probably could have solved it without optimization. No, actually, you wouldn't have been able to. But hopefully you were able to hang on. Okay, so let's do... trying to think of a practice problem. Okay, here's one that will be a little more complicated. We have a piece of cardboard. So, piece of cardboard that is 14 by 10 inches. So 14 by 10 inches. And we're going to cut out the corners and fold up the sides to form a box. So you've probably done this when you were a kid. Cut out the corners, fold the sides up. To make a box. So that means that this is H, this is H. Go around like that. You can't see up there. Okay, so the sides of those squares are H. Determine the height of the box. Ooh, great, the H's that we just put down. That will give the maximum volume. So since it's volume, length times width times height, we can plug that in. So V is equal to, we want the length, so that's 14. This is of the final box, keep in mind. It's minus 2h, because you have an h on each side. Let's erase that. So it's out of the way. You have an h on each side, so 14 minus 2h times 10 minus 2h times the h of the height. So if we multiply that in, we get 140. You can pause the video and do this by yourself, but it's just basic multiplication, so I don't expect you to have to do that. Minus 48h plus 4h squared times h. And if we multiply that in, and we kind of reorganize a little bit, 4h cubed minus 48h squared plus 140h. And then we take the derivative. So derivative of volume, 12h squared minus 96h plus 140. I encourage you to plug this into your calculator and figure out what your zeros are, but h is going to be equal to 1.918 and 6.082. We have to figure out which one of these values it is. So we have to plug back in to the volume equation. So that's this equation right there, or you can use this, depending on your preference, whichever one you prefer. You can use the alpha letter function on your calculator to plug into numbers if you don't want to have to use parentheses and type it in every time. But if you plug in 1.918, you get 120.9 24.164. Remember the 3 decimal point rule. And if you plug in 6.82, you get a negative number, negative 24.164. And again, logically, that is a 5. Again, logically, you can't have a negative volume, so it can't be that. So then height, since it was asking for height, has to be 1.918 inches. Yeah, that's it. I think that's a good start to get you guys going on solving optimization problems, and hopefully that was helpful. Thanks.